Today, we'll be picturing the limit definition of the derivative. My name is Vade Krishnan, and let's get started. In order to picture the limit definition of the derivative, we really need to understand that it's just transforming the slope of the secant line to the slope of the tangent line. Okay, so here's how we can visualize it. So let me sketch some general curve. Not an artist. Let me redo that actually. Not that great. I'll even redo this whole thing. Gotta work on my drawings here. Better. So let's say that points P and Q belong on this curve here. And what I'm going to do is form the secant line formed between these 2 points. Okay, so here is the secant line formed between these 2 points. So let's first look at point P. Okay, let's first look at point P. So we want to actually find the x and y coordinate pair which corresponds to point P. So in order to do that, I'm just going to represent the x coordinate which corresponds to point P as literally x. All right? And if we input x, I'm going to say that our output is f of x, all right? So now for point Q, in order to find the x coordinate which corresponds to point Q, I'm going to just call it x plus some distance, which is the change in x. Okay, now the reason why I'm denoting it as the change in x or delta x is because when the secant line turns into the tangent line, that delta x or that distance is going to change. All right, and you'll see what I'm talking about in just a second. So if we input x plus, or never mind, let me first say here that if we have x and x plus delta x, the distance between x and x plus delta x is, of course, delta x, okay? Remember that this is a distance. We'll, of course, come back to this later. So now, if we input x plus delta x, our output must be, let me use a different color here, sorry. Our output must be f of x plus delta x. So now, if we have 2 coordinate pairs, we can find the slope. Okay? So m secant, right? That should, of course, equal to, first of all, y sub 2 minus y sub 1 over x sub 2 minus x sub 1, right? This is our slope formula. So then let's first get our actual coordinate pairs. We can say that we have x comma f of x, right? And we have x plus delta x comma f of x plus delta x, right? I just showed you how we got that. All right? So now I can say that this is x1, y1, this is x2, y2. So then m secant will be f of x plus delta x minus f of x all over x plus delta x minus x. So then we can cancel out the x's in the denominator. So then we'll get m secant equals to f of x plus delta x minus f of x over delta x. Alright, so we just got the slope of the secant line. Well, how do we turn it into the slope of the tangent line? Well, in order to actually turn it into the slope of the tangent line, we need to see, let's picture what the tangent line will look like. The tangent line will look something like this, right? And what has to be true for this tangent line to occur? Well, in order for this tangent line to occur, the points P and Q need to get infinitely closer to each other, right? The points P and Q need to get infinitely closer to each other. Okay, to get infinitely closer to each other. Okay, so if the points P and Q get infinitely closer to each other, then this tangent line right here will occur. So while the points P and Q are getting infinitely closer to each other, well, what's happening to delta x? Well, delta x, the distance between the x coordinates, which correspond to point P and Q respectively, it will get infinitely smaller to the point where it just approaches 0. So that distance is getting infinitely smaller to the point where there just being no distance at all. It's approaching 0. It's getting infinitely smaller. So in order to represent the m tangent, you can say therefore m tangent, it'll just be the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. So hopefully that makes sense, right? It's just the points P and Q, which are the points that form that secant line, and that's how we got the slope. And we saw that slope for the tangent line occurs if we can find it if points P and Q get infinitely closer to each other. All right, so hopefully you understand how the limit definition works. But yeah, this is the limit definition of the derivative, visualized. See you in the next video.